All right, so we are going to talk about the third case today. Okay. Yesterday we talked about if the denominator had a larger degree, our horizontal asymptote was at y equals 0. If numerator and denominator had equal degree, we looked at the leading coefficients. Okay, so what's going to happen when we have the numerator with larger degree? We actually don't have a horizontal asymptote. We have what's called a slant asymptote. Okay. In this case, we're going to see only when the numerator is larger by 1 degree. You'll also hear these called oblique asymptotes. Okay. So what's happening is instead of a horizontal asymptote, we are going to get a slant asymptote. And I'll show you a picture here pretty soon. But it's basically going to be a line that has slope for your asymptote. Okay? So we're going to have kind of like a crisscross going on. We actually have to be able to find the equation of that asymptote, okay, since it's not straight up and down, straight across. It is at a slope. And this is where our polynomial work comes to help us. To find a slant asymptote, you're actually going to perform the division of your function. The quotient is the slant asymptote. You're probably going to get a remainder, but that does not matter. We just ignore the remainder, and the quotient is the equation of our asymptote. Here's an example of what it's going to look like. Hey, don't graph this for me, okay? But this is just giving you an idea of, we have a vertical asymptote and we have a slant asymptote. Okay? It looks like that's the equation y equals x plus 2. Okay? So the degree of the numerator is 1 higher. That's a red flag. Okay, we have a slant asymptote. To find it, we perform the division ignoring the remainder. Okay. If it were to divide evenly, then that means you have factors that you can cancel, and you would have a whole. Okay, so you want to make sure you simplify before looking at your division. Okay, that's the first step of our graphing. But when our degree in the numerator is 1 higher, we get this slant asymptote going on. Okay, good news, I'm not going to make you find the range of a slant asymptote problem. Okay, I'm only going to worry about the domain, but that's like, this is like the only graph that you'll get that free pass for. Okay, so let's do an example. Our very first step with any rational function is to factor, just in case we can simplify. Oh man, that's really slow. Okay. Can we simplify? We cannot. However, having the numerator factored, okay, if we set the numerator equal to 0, we have x-intercepts of 0 and 1. Okay, that is how the numerator is helpful in that case. Okay, more on that later. Let's talk about our vertical asymptote. Keegan, where's our vertical asymptote? X equals -1. Thank you for saying it as the equation of a line. Okay, there we go. Now we need to talk about the horizontal asymptote. Is there a horizontal asymptote? Okay, you didn't even know that was a possible question until today. But what do you notice about the degree of the numerator? It's larger, correct? So we are going to have a slant asymptote. Okay, so we need to perform the division. I don't care what kind of division you perform, okay, but you can only do synthetic division if we're dividing by a linear divisor. Is our denominator linear? It sure is. So we can perform synthetic division. So our numerator is x squared minus x plus a 0 constant. That is important to have zeros for missing terms. And we're dividing by x plus 1. We're going to put -1 outside of the synthetic division. Okay. So here we go. Carry the 1 down. 1 times -1 is -1. Add to -2. Okay. I'll go ahead and do it. We get a remainder of 2. When we're finding a slant asymptote, you should get a remainder. But the remainder doesn't matter. Okay? I don't care what the remainder is. This right here, this linear equation, is giving you your asymptote. So our slant asymptote is y equals 1x minus 2. Okay. Now we all know how to graph lines, right? We did that way back in middle school, practically. Okay. Y equals x minus 2, so we have a y-intercept of -2, and then we have a slope of 1. Okay. It's not the most fabulous line, but it's going to have to work for right now. Okay. Looks kind of crazy, right? All right, so now we got to get some coordinates on there, okay? Nothing has changed with my expectations for you graphing. The only thing that's different is you need to recognize that, first of all, there is a slant asymptote, and you need to know how to find it. Otherwise, everything else is the same, okay? Okay? And our graph is just a little funky, okay? So basically, we are going to have, if you think back to, let me go back to geometry here. Do you remember when you had two intersecting lines and angles that are across from each other were vertical angles? Do you remember that? Okay, so your graph is going to be in a pair of vertical angles. We basically have to figure out just which pair of vertical angles our curves are going to be in. Okay, so if our vertical asymptote is at x equals -1, what is to the right of that that would be nice to plug in? 0 and? Okay. So way back to our original function, when we plug in 0, what do we get? 0. When we plug in 1, what do we get?
0.
Yep. Okay, Mrs. Homan, how can that happen? Two coordinates right next to each other have the same y value. Okay, yeah, it looks kind of funny, but this is what's happening, right? We know we have to approach the asymptote. So we kind of have this strange U shape going on. So we know at least the other piece of the graph is going to be across from it right here, but we need the points, okay? So vertical asymptote at -1, let's plug in -2 and -3. Help me out. When we plug in -2, what do we get?
-6.
And when we plug in -3, okay, and that should happen, right? You should have some symmetry going on. So 1, 2, 3, 4, 5, 6, and 6. So we have that same kind of thing happening. Do you see how finding the range could be difficult in this problem? Okay. We know we don't have y values in between here, but we don't know exactly where we're making that turn. So I'm not going to make you find the range. I'm only going to make you worry about the domain of a graph with a slant asymptote. Okay. So our domain, Callie, what would it be? Okay, what is our rule for all rational functions and their domain? What do we need to look at? Like on the problem that you did this morning, what did you look at to find the domain? You excluded which numbers? Okay, so where can our x's not go? Right here. Where's the one place that you know it's not going to cross? Our x values. We plugged in a -2, didn't we, for x? Are you thinking of y?
Maybe.
I think you're thinking of y. Let's think of x's for domain, right? Okay, good. Let's think of x's. What number is not allowed in the denominator?
-1.
Okay, whatever is not allowed in the denominator, that is what we need to exclude from our domain. So since we cannot divide by 0, -1 can't be plugged in. That's where our vertical asymptote is. We exclude it from the domain. Callie, the range, we're not going to worry about because, right, you looked up here and you're like, I don't know how to say it, right? We have this gap, but we don't know where that gap is particularly, okay? So we will not worry about the range. All right. What do you think? Okay. Shall we do another one? For good practice? We might as well. We have 10 minutes. our first step, what is it? Factor. What can we do in the numerator? What can we do in the denominator? Take it an X. Oh boy! What happens? And what happens when we cancel out factors? There is a hole. Okay? So our simplified function is x squared plus 4x plus 3 over x plus 2. And when we graph that, we better make a hole where? At 0. Okay? Interesting. Okay. Let's talk about our vertical asymptote. Chris, where's our vertical asymptote? X equals -2. That is where our denominator is 0. Okay. Tiger, will we have a horizontal asymptote? What will we have? Okay, our numerator is larger in degree, so we are going to have a slant asymptote. Let me get this down a little bit so I can get my work. Okay. What kind of division can we use? Synthetic. Whatever you prefer is fine. Synthetic division, in my opinion, takes up less space on my paper, and I'm going to try to save some space here this morning. I'm going to use synthetic. So we're taking x squared plus 4x plus 3, and we're dividing by x plus 2. So we're going to throw -2 outside. Okay. You perform the division as I do it up here. I'm not going to speak aloud, but you do it on your paper without me. All right, remember, you will get a remainder, and we don't care about it. Our slant asymptote is going to be this right here, 1x plus 2. So we have the line with a y-intercept of +2. And slope of +1. Okay. Now it's just a matter of plugging in points. Okay. To the right of our asymptote, what coordinate should we plug in for x? -1 and 0. Now let's be careful. What did we decide was happening at x is 0? There is a hole. Okay? Always go back and plug into the original. If we plug in -1, you get 0?
Yeah.
Yeah? And when we plug in 0, we get 3/2. Okay, so -1, 0. At 0, 3/2, we have a hole. And then we know that the behavior of our graph should approach the asymptotes. Yeah.
Would you consider 0 3/2 an x-intercept if there's a hole? I mean, a y-intercept if there's a hole over the y-axis? Or would you not consider it a y-intercept?
That is an excellent question. technically, it is not crossing the y-axis. So there is technically not a coordinate on the y-axis. It would not be a y-intercept. Now, visually, we see it like going through right there, right? But technically, it would not be. Next question. All right. To the left, -3 and -4. Do we get 0 for -3? Yeah. And -4, we would get 16 minus 16, -3/2. Okay, you're going to see that kind of symmetry. Cool. So then for our domain, we are going to need to exclude both the vertical asymptote and the whole. I do not know what's going on with my projector right now, but so we have to exclude the vertical asymptote and the whole. Put your name at the top of this piece of paper. On this small piece of paper, there are a variety of emojis. I would like you to put your name, and I would like you to circle an emoji that describes how you feel about rational functions, and then explain why. Now, please make this mathematical. Okay? Do not be a smart mouth. Okay? I want your honest opinion of why you feel this way. Okay?